What is artificial intelligence? Artificial intelligence is the simulation of human intelligence in machines, enabling them to think, learn, and solve problems. What is machine learning? Machine learning is a subset of AI that enables computers to learn from data and improve performance without explicit programming. Difference between AI and ML. AI is the broader concept of machines simulating intelligence, while ML is a technique that helps machines learn from data. How AI and ML work together. AI and ML work hand in hand, where AI provides the intelligence framework, and ML refines its accuracy through experience. Supervised versus unsupervised learning. Supervised learning uses labeled data for training, while unsupervised learning finds patterns in unstructured data. Deep learning in engineering. Deep learning, a branch of ML, uses multi-layered neural networks to make complex engineering predictions and decisions. Neural networks explained. Neural networks mimic the human brain, processing data through layers of interconnected nodes to recognize patterns. AI in robotics engineering. AI powers robotic engineering by enabling automation, intelligent decision-making, and precision in industrial applications. AI-powered automation in industry. AI-driven automation optimizes manufacturing, reducing errors, increasing efficiency, and enhancing productivity. AI in decision-making for engineers. AI helps engineers make data-driven decisions by analyzing trends, predicting outcomes, and optimizing processes. AI in mechanical engineering. AI revolutionizes mechanical engineering by enhancing design, predictive maintenance, and manufacturing automation. AI in civil engineering. AI assists civil engineers with smart infrastructure planning, structural analysis, and real-time construction monitoring. AI in electrical engineering. AI improves electrical engineering by optimizing power distribution, fault detection, and smart grid management. AI in automotive engineering. Self-driving cars, predictive maintenance, and AI-powered diagnostics are transforming automotive engineering. AI in aerospace engineering. AI enhances aerospace engineering through flight path optimization, predictive maintenance, and autonomous systems. AI in structural engineering. AI predicts stress points, optimizes material usage, and ensures structural integrity in construction projects. AI in industrial engineering. AI optimizes workflows, supply chains, and production efficiency in industrial engineering. AI in chemical engineering. AI accelerates chemical engineering by predicting reaction outcomes, optimizing processes, and reducing waste. AI in biomedical engineering. AI-driven innovations in biomedical engineering are advancing prosthetics, medical imaging, and robotic surgeries. AI in environmental engineering. AI monitors pollution, optimizes waste management, and predicts environmental risks for a sustainable future. AI in smart cities development. AI enhances smart cities with intelligent traffic management, energy efficiency, and automated public services. AI in energy optimization. AI-driven systems optimize energy consumption, improve grid efficiency, and support renewable energy solutions. AI in supply chain management. AI improves supply chain logistics with demand forecasting, route optimization, and automated inventory tracking. AI in material science and engineering. AI accelerates material discovery, optimizing properties for strength, durability, and sustainability. AI in predictive maintenance. AI detects early signs of machinery failure, reducing downtime and maintenance costs in industries. AI in digital twin technology. AI-powered digital twins create virtual replicas of physical assets for real-time monitoring and optimization. AI in smart manufacturing. AI enables smart manufacturing with real-time monitoring, quality control, and predictive analytics. New line. AI in 3D printing and additive manufacturing. AI optimizes 3D printing by enhancing precision, reducing material waste, and improving efficiency. New New line. AI in cybersecurity for engineers. AI strengthens cybersecurity by detecting threats, analyzing risks, and securing critical engineering data. New line. New line. AI in renewable energy systems. AI maximizes renewable energy efficiency by predicting solar and wind power generation trends. New line. New line. AI and ML in edge computing for engineering. Edge computing powered by AI processes engineering data in real time, reducing latency and increasing efficiency. New line. New line. AI in sustainable engineering solutions. AI promotes sustainability by optimizing energy usage, reducing waste, and improving green technology. New line. New line. AI in IoT for engineering applications. AI and IoT combined to enable smart monitoring, predictive analytics, and automation in engineering. New line. New line. AI in disaster prediction and management. AI forecasts natural disasters, enhances emergency response, and minimizes damage risks. New line. New line. AI in smart grid technology. AI revolutionizes smart grids by balancing power supply, demand, and efficiency. New line. New line. AI in AI-assisted CAD design. AI accelerates CAD design by suggesting optimized engineering models and automating repetitive tasks. New line. New line. AI in healthcare engineering. AI-driven diagnostics, robotic surgeries, and smart medical devices are transforming healthcare engineering. New line. New line. AI in space exploration. AI assists space exploration by analyzing planetary data, optimizing spacecraft performance, and enabling autonomous rovers. New line. New line. AI in nanotechnology and microengineering. AI aids nanotechnology by designing self-healing materials and ultra-precise microengineering solutions. New line. New line. AI in self-healing materials. AI discovers materials that autonomously repair cracks, extending durability in lifespan. New line. New line. The future of AI in engineering. AI is shaping the future of engineering by enhancing automation, efficiency, and innovation. New line. New line. AI in ethical engineering decisions. Ethical AI ensures responsible engineering practices, preventing bias and ensuring safety. New line. New line. Challenges of AI implementation in engineering. Despite its benefits, AI faces challenges such as data privacy, adaptability, and ethical concerns in engineering. AI and ML in engineering education. AI is transforming engineering education with virtual labs, AI tutors, and interactive learning modules. New line. New line. AI in autonomous systems and robotics. AI-driven autonomous systems and robotics are revolutionizing engineering by enhancing precision and decision-making. New line. New line. How AI is reshaping traditional engineering methods. AI is replacing conventional engineering approaches with data-driven, automated solutions. New line. New line. AI and ML for engineering research and development. AI accelerates R&D by processing vast data sets, simulating models, and optimizing engineering innovations. New line. New line. AI's role in reducing engineering costs. AI minimizes costs by optimizing resource allocation, reducing errors, and improving efficiency. New line. New line. Top AI tools and software for engineers. AI-powered software tools are revolutionizing engineering with intelligent design, simulation, and automation. New line. New line. How engineers can adapt to the AI revolution. Engineers must embrace AI by learning new skills, using AI tools, and integrating automation into their workflows.